In this video, I would like to go back to my two examples. The examples that I did where I converted vertex form to standard form to vertex form, and found all the properties. And I'd like to actually show you the graphs, both using GeoGebra and also on your graphing calculator. So for my first example, number 1, let's just say I started with the vertex form y equals 4 times the quantity x minus 3, the quantity squared plus 1. I got that because a was 4, h was 3, and k is 1. So I should have been able to identify my vertex as h comma k, or in this case 3 comma 1. And as you can see, that in fact is exactly where the vertex arrived. Now because the vertex is the point that the axis symmetry cuts through vertically, I should be able to write my equation x equals 3 right over here. As you can see, the axis symmetry goes right through there. Now, because my A is positive, the direction of opening happens to be up. This tells me that my vertex is going to be the lowest point of the graph. Therefore, all the points will have at least a minimum height of 1, which happens to be the same as my k value. And because it's a minimum, that's going to affect my range. Now, the domain is always all reals, but the range will be y is greater than or equal to 1. What I would like to show you right now is how to get that on the graphing calculator. So ahead of time, I graphed y equals 4 times x minus 3 quantity squared plus 1. Now I'm going to turn off the standard form because let's pretend I don't know what that is yet. And I'm going to have done a z-decimal, so I'm just going to go ahead and hit graph. And you will see that it looks like that. That's pretty much the same parabola that's over here. But what I really want to do is get the coordinates, and it's not as easy. I mean, it looks like it's 3 comma 1, but it would be a lot easier if the calculator could tell me. So if I hit second trace, I'll pull up the calc features. Now, knowing that it was going up means that this had a minimum. So I'm going to choose option number 3. Now it's going to ask me for a left bound, which means I need to set my cursor to left of this vertex. I am left of it, but it's very hard for you to tell if you're not paying attention to these coordinates down here. So a lot of times, students feel much more comfortable if they actually see the cursor. So there you go, I brought the cursor over, and as long as I'm left of this, I can go ahead and enter. I have to be right of this. So now that I'm right of it, it doesn't matter where I hit enter. I'm going to hit enter here. As long as the vertex falls between these two arrows, I should be able to find it. Now there's only one vertex, so I really don't need to guess. I'm just going to go ahead and enter, and you'll see that I came up with coordinates that are very close to 3, 1. Well, due to the algorithm and the rounding errors that occasionally come up because of the algorithm, it sometimes does not actually give you the exact answer for your vertex. I can pretty much tell, though, that with 3, followed by a bunch of zeros, that for the most part, that has got to be x equals 3, and the y equals 1 is, well, exact. Don't be surprised if some other time you do this, it may have came up as 2.9999987. Be smart about it. Assume that the value is 3. And once you know that the minimum is, once you know the vertex is at 3, 1, you can figure out your axis symmetry, x equals h, x equals this coordinate. You can identify the min or the max, depending on which way it's going. This one even tells you minimum, so the minimum value is 1, and you can go through and add the properties. Now let's say you do convert to standard form, and you come up with 4x squared minus 24x plus 37. Remember, this 4 and this 4 do the same thing. It tells you it's going up. The 37 of the value of c is going to tell you your y-intercept. So for you to see that, I'm going to have to drag my graph all the way up to this value here so that you can see the y-intercept is at 37. Now, it's crossing the y-axis. I don't see the graph crossing the y-axis, and I could try changing the window settings when I do so. But really, I don't need to do that. If I go back to second trace, and I go ahead and hit value, just remember, the y-axis is when x equals 0. So if I go ahead and hit enter, even though I don't see the coordinates, even though I don't see the actual point on the graph, the coordinates do show up here on the bottom, and my y-intercept is the same 0.37 as is over here. Now, one thing that I would be concerned about is, Did I even do my standard form correctly? So, as you can see, I typed both of them in, but I did not actually activate Y2. I'm going to go ahead and hit Y2 right now. The problem is the first graph and the second graph, I have no idea if the graph is like way off course or if it's right on top of each other. I'll never know the difference. So it'd be wise for me to change what Y2 looks like. So one option is I can come over to the far left, choose it so it'd be a thick line, so that the first graph is a thin line, the second graph is a thick line. Hey, look at that. They're the same graph. Another option is to come back over here and maybe use one of the options where you see a little hollow circle. I'm going to use the little hollow circle where it traces. So again, the first graph will get done, and then the second graph should come right over with the little circle. Oh, look at that. The two graphs are the same. So that's how you can use your graphic calculator to help identify just as many of the properties as a program like GeoGebra does. We're going to do it again right now with the second equation.